As a second video of today, let me discuss how to apply the Castiglione theorem for statically indeterminate problems. So before talking about Castiglione theorem, let me give you a short review. So as a first method to attack this problem, we considered a simple beam theory and double integration method, and this is the copy from one of the previous lectures. And what we found here is that when we have to solve this problem based on conventional method, we have to handle many unknowns, 5 unknowns, 7 unknowns, 10 unknowns, depending on problems, and it's quite I would say irritating and tough to handle many unknowns, even though we are guaranteed to find solution because we have 5 unknowns and 5 linearly coupled linear equations. Then the second method I suggested you was the usage of the superposition method. The disadvantage of this method is that we have to have a table of known solutions. If we happen to have a problem that does not have any known solution table, we have to solve for that that problem and try to obtain the answer in quite difficult way. So superposition method is convenient, but there is disadvantage. Whenever you choose several options, typically each options have pros and cons, and it's in most cases there is no ideal and perfect option that is superior to all other available options. Okay, that's life and that's engineering. Okay, so let's consider third method, Castiglione theorem. Okay, so how we can approach this redundant loading problem. Okay, so here, this is typical redundant loading problem. Without this simple support, this guy can satisfy mechanical equilibrium by bending this beam. However, by placing this additional simple support, due to this redundant support, you happen to have 3 unknowns: FA, FB, and MB. However, because we are considering this quasi 2D problem, there is only 2 mechanical equilibrium equation available, Fy summation to be 0 and M summation to be 0. So we call this as a statically indeterminate problem. So to approach this problem based on Castiglione theorem, here's what I can suggest. We can replace this simple support with a force Fa. Still, it is unknown because there is 3 unknowns. Then what you do is you write down m as a function of x, which is gonna be function of f, right? If you write down mx in terms of f, what you can do is you can write down u as a function of m, which means that u will be function of f. After obtaining the strain energy u as a function of f, what you do is you consider partial u and partial fa. What's the physical meaning of partial u and partial fa? The physical meaning of this guy is a deflection at A point, and the constraint on the A point is due to this simple support, deflection at A point should be 0. Okay, so that's the constraint you can have, and after adding this equation, you have originally 1 and 2 equations. Now you have a third equation, partial u, partial fa, and what you're gonna have is that you're gonna have third equation. After obtaining third equation, which include fa, and if you have already 2 more equations, you have a total 3 equations, and you have 3 unknowns, and you are guaranteed to solve a problem without increasing number of unknowns. Okay, so this gives you another option to solve the problem, and let me give you an example problem that you can apply the Castiglione theorem for statically indeterminate problem and so solve the problem relatively easily compared to other 2 methods. Okay, so the problem we're going to consider is extension of previous structural equilibrium problem. In previous problems, we didn't have this redundant support, and without this redundant support, we were able to satisfy mechanical equilibrium, and we discussed how to obtain the deflection along vertical, deflection along horizontal direction based on Castiglione theorem. Here, additionally, let's solve this problem which is the statically indeterminate problem based on Castiglione theorem. Okay, so in here what you have to focus is that there is rigid wall, and this is rigid, this is rigid, and this is rigid. Okay, so we have rigid ceiling and we have rigid support, and there is no displacement. Okay, given this condition, let's try to formulate this problem. As I told you, there is three unknown forces: FAB, FBC, and FBH. These forces used to be quite easily obtainable in terms of P. However, due to this redundant force from the top, now it's quite tough to obtain these unknowns. So there is three unknown forces. However, as I told you, for this quasi 2D problem, we can have only two equations. Summation Fy should be 0. Summation Fx should be 0. There is no concern about moment, because everything is two force members, and at the end of their joint, there is nothing to support the side wall, and it's a freely rotatable joint, so you cannot consider any moment. So there is two equation, and there is three unknowns, and you can say that this is a statically indeterminate problem. So what you're gonna do is we're gonna take a similar approach. So here what we're gonna do is following. So we're gonna consider this structure a part of that structure under two forces P and RH. Okay, RH is the force from this top support, and what you're gonna do is we can write down U as a function of P and RH, and because the top point is constrained to a rigid structure, you can say that YH, which can be defined as partial U and partial RH, to be 0, and it will give you third equation. And after having third equation and using first and second equation together, you can obtain the values for FAB, FBC, FBH in terms of P. Okay, so let's try to do so. So the FAB, FBC, and FBH, yeah. So let's try to write that in terms of P and RH. First, at H point, at point H, you can think about equilibrium between FBH and RH, and as expected, RH and FBH should have same magnitude. Okay, and regarding this B point, here you have FBH and FBC and FAB, and FBH can be written as RH. Okay, so what you do is after writing down this two vector equilibrium diagram, you can write down FBC, you can write down FAB in terms of P and RH, P and RH. After obtaining FBC, FAB, and FBH in terms of P and RH, you can write down U as a function of P and RH. Okay, so let's do that. So if you plug in FBC, FAB, FBC in terms of P and RH and P and RH, then as I told you, after obtaining U, if you perform partial U and partial RH, it physically means deflection along the vertical direction at H point, and H point is exactly the point which is adhered to the rigid structure, and this is point should be 0, deflection should be 0. So if you solve this derivative for each term, you have a partial F, partial H, partial F, partial RH, and partial F, partial RH term. After plugging the values and perform this derivative, you're gonna end up having 0 equals to be 1.228 RH minus 0.728 P. That will give you the third equation. So after combining third equation with first two mechanical equilibrium equation and identifying that there is three unknowns, what you're gonna obtain is in the end FBC, FAB, FBH in terms of P. Okay, so after obtaining these three values in terms of P, you can obtain the deflection. You can obtain the deflection along horizontal direction in relatively easier way. Okay, so as you can see here, we already discussed about two method to approach a statically indeterminate problem, but as we learn a more way to approach the same problem, which is called Castiglione theorem, we have quite useful and nice weapon to attack the same problem. Okay, so you know you know this is the last lecture regarding the energy method, and what you can see here is, as we have done back in freshman physics, depending on the problem, yeah, sometimes method 1 is easy, sometimes method 2 is easy, sometimes method 3 is easy, and as we have done for freshman physics, I offered you a new method called energy method as an alternative way to solve statically mechanical equilibrium problem and mechanical deformation problem, and hopefully this gives you a useful way and way to solve problem, useful way to think about what mechanical equilibrium and what mechanical deflection is. Okay, so with that, let me wrap up the last video regarding the energy method, and in the final lecture I'm gonna give you summary for the concepts we have covered until now to prepare the final exam. Okay, so with that, let me finish my today's lecture here. Okay.